What's going on, my Algebra 2 students? Let's get this party started with, I'll tell you what we're going to do is some people were having trouble with this Expo 3 Part 5 or whatever it is. It's like 44 points or something like that. And they were getting all messed up, and so I figured I'd help them out. Maybe do one or two example problems. Sound good to you? And then what I want to do... Oh, which one are you guys talking about? Which one do you guys want help with? Is it the one that's due today or the one that's due on Wednesday? Or not Wednesday, but on, yeah. The one that's due today probably, yeah. All right, cool. So why don't I just do a few of these for you? Okay, cool? All right, so check this out. These are actually really easy, I think. No, they're really easy. All right. I think maybe the best thing to do would be to show you my camera screen. Give me a second. My computer froze. Okay, so you're trying it now? All right, let's do it. Let's do it together. Whoa, whoa. Sorry, hold on. I'm gonna have to reload it. My computer froze. What up, dudes? Can you hear my voice? Arrgh. But this thing's not letting me do the camera. Okay, wait. Audio check. Audio check. Good. Video camera check. We good? Up and running? All right, let's do this. Size 18. Bring your computer up there. Let's go get up on the board. All right, am I recording? Good, we're recording. Okay, good, cool. Let's do this one. So, let's do that first problem over there. What is it? It's 3, 7, what were the numbers?
660.
660, right here?
Mm-hmm.
And what?
966.
966.
0.306.
0.306, all right. You're going to need to be on calculator and quick style. Cool? All right, so check this out. The general formula that you guys have is f of x is equal to c times a to the x power. And what you do is, in order to figure out what a is, you just take the ratio of these two numbers. Got it? Got it? You just take the ratio. You take 966.306 divided by 660. But that's not actually true. Here's where the big complication comes in, right? Is that that's true if these are consecutive numbers. If this is 3 and this is 4. or if this is 6 and this is 7, if they're right after each other. Does that make sense? But the way I've explained it to you in the past is I said, well, here's what's really going on. 3, 4, 5, 6, 7, 660, and 966, you said?
Yep.
0.307 or something like that? 607?
306.
306? All right. So what's happening here, yeah, you guys already picked up on this idea here, is what's happening here is the ratio between here to here, that's that number right there, R. It's this jump right here. But the A value that you're trying to get is the number you multiply it to get to the next number. So how many times do you have to multiply it to get to the next number? How many A's do I have to go through in order to make one of these giant jumps? 4. Exactly, very good. And so I know that A to the 4th power is equal to R. Got it? And then what I'm trying to do is I'm trying to solve for A. I'm going to give you guys the universal way on how to solve these problems every time. Cool? I want to solve for A over here, meaning basically I want to get A all by itself, or maybe more accurately, A to the 1st power all by itself. Cool? So what do I do to the 4th power to get rid of that 4th power? I take the 4th root. Good. One way to do that is a symbol that looks like that. Of course, you got to take the 4th root to both sides, so you do that. But here's the problem. I like that idea. That's perfectly fine. The problem is you guys don't know how to put that into your calculator. Am I right? What the heck is a 4th root? So, another way to write the 4th root, I mean, think about it. Remember I told you that one property that a number or an exponent to an exponent, you multiply those exponents together? And I want to make this exponent over here to be a 1. So what is a number I can multiply 4 by to make it equal to 1? One-fourth. Something to the 1/4 power is exactly the same as taking the 4th root of it. And that you know how to plug into your calculator. You just plug in some number with a caret and then, parentheses, 1 divided by 4 and then close parentheses. Did you guys catch that? Do you understand what I'm saying here? You know how to make A to the 1/4 power on your calculator. You might not know how to do the 4th root. But it's the same thing. A 4th root means to the 1/4 power. So right. But you have to do 1/4 of both sides. So what happened is, what is 4 times 1/4? Just 1. Yeah, 1. And that's what we wanted, right? A to the 1 is the same as A. So that's kind of the point. That's how we undid the 4th power. And then over here, this R was 966.306 divided by 660. Can you tell me what that number is? Use a calculator, obviously. Unless you're that good. 1.1? It is? 1.1? So, this R was 966.306 divided by 660, and that's how you got 1.1, right?
Oh, no.
No, wait.
1.41.
Oh, this is 1.41. 1.1 happens after you've taken the 4th root.
Yes.
Okay, I see. When you do 1.41 caret, and you can do 2 things, all right? You can plug into your calculator exactly this, 1.41 caret parentheses 0.25 close parentheses. That's what it's going to look like on your calculator. You'll end up getting your answer is 1.1. Are we cool? All right. So we figured out what A is. Here's okay, to be honest with you, I don't have a calculator on me. Let me go grab one real quick.
Oh.
I don't ever use calculators.
It's 1.46.
Oh,
That's
you
probably
accidentally messed up the
Yeah, I think I messed up.
All right. Sorry. I'll tell you what. I'm sorry, you guys. I'm gonna have to trust your calculator skills because I don't have mine on me. Yeah.
6.
Okay. Wait. So what is this number?
46.
1.46. And then when you take that to the when you
It
take
does
that to the
0.25.
1 or 0.25 power, what is it? 1.1. Yeah. Bradley, take 966.306, divide that by 660. Yeah, the ratio is just this number divided by this number. Okay, now, the only thing that this right here is the general equation. It only has no numbers, it has only variables. Okay? The only thing that I could really change up on you is where did we get this 4 from? Where would you describe that 4 coming from? Like without having to draw a picture and say, oh, I multiplied it by A 4 times. It's this right here. There we go, Bradley. That's exactly it. It's the difference. It's 7 minus 3. Got it? So maybe what I can do is if I wanted to make it look more like a formula, I'll call it A times x2 minus x1 equals R. This isn't a new formula. This really isn't. I don't want you memorizing this or anything. I'm just saying, for general problems, for any problem, you can just say, whatever the x value is in the second x value minus the first value, that's what you put in the exponent. You guys get it? All right, cool. So I think that one of the things that I did was I did a different problem where there was like a 0.5 here and a 1 over here. I can't remember what the numbers were over here on this side. I think it was like 3 and 9.
3090.
Oh, well. 3 and 9 would have done the same thing, but it's 30 and 90. Okay, good. So check this out. What is R? What is my ratio between those two numbers? It's just 3, right? 90 divided by 30 is 3. Bradley, you get that? You understand? All right. Are these consecutive? No, they're not. So I have to play this trick where I say, well, a to the some power is a to the some power is equal to 3. And that some power is 1/2. Right? Because 1 minus 0.5 is 0.5 or 1/2. We cool? All right. How do I get rid of that 1/2? You square it. Very good. The reason why I showed you this problem is because for the most part, what we've been doing is we've been taking whatever number goes here and bringing it to the fraction power. You know, like if it's a 4 power here, I raise it to the 1/4 power. Or I take the inverse of that and I raise it to that power. For this one, we're actually doing exactly that. We take a 1/2 and we invert 1/2 and we raise it to that power. What's the inverse of 1/2? It's just 2, because 1/2 flipped over is 2/1. So that's why I'm squaring it. And it looks a little bit different, but if I were to write it like this, I don't think any of you would complain about, hey, you got to square both sides to get rid of that square root. You know what I mean? So what is your A value in this case? Your A value is actually 9. Are we cool? All right, the other complication is to figure out what the C value is. And the C value is simply, you go f of x is equal to C times 9 to the x power. And then you say, gee, wouldn't it be great if I knew at least one point where this thing actually ended up being a true, a point that's on this graph? And you say, well, I happen to have 2 points, 1 and 2. Let's choose one of them. In fact, to be honest with you, I'm going to choose this one right here. In fact, I love the way Sophia put it. Let's do 90 equals C times 9 to the 1 power. 9 to the 1 power is 9, so C is equal to 10. Any questions, comments, vomits, etc.? All right. So for this entire homework set, the only complication that I added was that extra bit of stuff that you needed to do to play with that exponent. You can't just take this number and divide by that number and you'll get your A value. Right. This entire section is on non-consecutive integers. That's what it is. That's all I did. Ooh, mess with your heads. No, not really. In fact, to be honest with you, it's almost like an easy 3 points. I think that I set the margins for a lot of these homework assignments too small. And so a lot of you were complaining to me and saying, hey, why am I getting all these wrong answers? I've been double checking it. You must be wrong. And actually, I've been doing it right. The thing is, I've set the margin so high that you need to get the exact 4 decimal places that I put in order to agree with me. And I always think that's ridiculous. I didn't like doing that to you guys when I was teaching you guys chemistry. When I teach physics, I give you guys this huge margin of error. So what I need to do is go in, and a lot of times I'll just have to go in and fix the margin of error. I apologize if it gets messed up. If you guys are doing this homework set and you guys are like, I'm doing it right and I keep getting the wrong answer, chances are you're doing it right and you should be getting the right answer, but Mr. Daldy is too much of a jerk to give you the guys the right answer. Of course, Mr. Daldy is not too much of a jerk. I just seem that way and I will fix it. Sound good? All right, let's apply this to our lives, because I keep telling you, what is my favorite question to ask in mathematics? Come on, you guys know this one. Why? Why the heck are you teaching this? Why should I care? What is the point? All right. This this exponential stuff might be, I don't know if it's complicated. Is it complicated? Has it gotten complicated yet? Not really? Okay. Some of the stuff you're going to be learning in the next week or so is going to be like, wow, where did that come from? But to be honest with you, this topic is deceivingly useful. And it's not even deceivingly useful, it's deceivingly useful in your everyday life. And the reason why I say deceivingly useful is because I didn't realize how powerful it was until I took higher courses and more courses, and I realized, oh snap, this stuff shows up all the time. And the one particular place that it shows up in is economics, as Sophia pointed out. You know, when you put your money inside of the bank, it occurs interest. It occurs interest, or whatever. Yeah, and it shows up a lot on the SATs as well. But because something shows up on the SATs isn't a good motivator for you to learn it. That would be like you saying, why should I know this? And I say, because I said so. I hate it when people do that. But I guess what I'm trying to say is that, like, this has a lot to do with money. A lot to do with money. And I really think that regardless of whatever you go into, you might be interested in how it affects the money that you have or the money that your company has or whatever. So knowing this stuff is actually really important. Cool? All right. To be honest with you, I don't necessarily think there's anything... is there anything relevant or good in Chapter 5, in Expo 5? And my answer is no. No. It's not necessarily that it's not relevant or good. It's that there's nothing that's necessarily like different or new. We're just applying it to... Oh, Lucas, I'm talking actually about past homeworks as far as my margins being tough. If you find that my margins are tough, let me know, and I guess you know me, I will adjust it to be reasonable. I hope that you've never experienced a case where Mr. Daldy is like, no, I want you to write down all the 5 digits that I wrote down, and it has to be exactly the same ones. Unless, of course, you're doing chemistry or engineering, and it needs to have a certain level of accuracy, then I'm a jerk about those kinds of things. Because if you mess up you put in the wrong amount of numbers, you're going to blow things up. Especially you, Bradley. The reason why I said that is because you want to be an anesthesiologist. So you need to know exactly how accurate you need to be and be that accurate. Or you'll kill people. Okay? No pressure. No pressure. All right. Anyway, I'll tell you what. For Chapter 5, why don't I just do some of your homework for you? Sound good? All right. Chapter 5 is all about, it's still about this form f of x equals c times a to the x power. The only thing is we're going to change up certain things. We're going to change up the letters. Okay? Remember when I originally introduced this to you? I introduced this to you as a times r to the x. And I hated that they made this switch. I still, to this day, do not understand why they've chosen these letters. I've now made the switch over to these letters just because I don't want to confuse you anymore. But all I'm doing is I'm changing the letters a little bit, right? So you might see an equation that looks kind of like this, but we're going to use different letters. Is the actual formula y equals a times b to the x? I have no idea, to be honest with you. I thought it was a times r to the x. That's what I thought it was. But apparently it's not. Apparently they didn't want to do that. Apparently they wanted to do something stupid like put a over here, right? And that has nothing to do. This is the gummy bear factor, and we usually call that a. So why not call that a in the first place? I don't know. All right, anyway. You might see it like this. Okay? Don't freak out. It's not a new equation. It's the same equation using different letters. Same exact everything. Why the heck would we change the letters? Okay. Well, because we're applying it to a different scheme. Like, for example, if we're applying this to money, we don't measure things in x, a distance. We measure things in time. So wouldn't it make sense to change our variable, the thing that we are allowing to change the increments of, to be a t instead of an x? Cool. And then this r over here, that stands for rate, which makes perfect sense, okay? This p over here, so this p and this p naught is different. I don't know if you took chemistry from me, but I call this p with a little zero, I call it p naught. It just means the initial p. And what this is referring to is it's talking about the word principal. And when you invest money, you're investing a principal amount. That's what it's called, I guess. I don't know. I'm not very good with money. I don't got much of it, so I don't got to do much investing. But I'm just saying, is that P is your initial investment. So this is the amount of money you get is the initial investment times the rate to the time to the t. Does that make sense? All right, you got to go? Okay. So all I'm doing is I'm changing the letters on you a little bit. All right, let's see. So here's number 4 on chapter 5 homework, which is Expo 5 homework. It's talking about let's do it this way. The principal amount that you have is 500 times 0.8 to the t power. All right, let's answer some questions based off of it. All right, this is talking about some radioactive decay after t amount of years. So I have some kind of radioactive material that I bury in the ground. And radioactive material has a half-life. What a half-life means is it decays away. It actually changes from one isotope to another. Let's say uranium. And so the first question is, how many grams of the element did you have initially? Now, Sophia loves to call this the y-intercept. And I keep cringing about that, but actually Sophia's absolutely right. It's the y. This is the y-intercept. This number right here is how much you have initially. The reason why I cringe is because that's not always true. That's not always true when it comes to like parabolas and cubic functions and all of that kind of stuff. That a value doesn't give you your y-intercept by any means. But in this particular case, it does. And the reason being is because to find the y-intercept, or to find the starting point of something, you plug in t equals 0. If I plug a t equals 0 here, it doesn't matter what this number is, because something to the 0 power is 1. So essentially I can get rid of that. And then the rest of it is my y-intercept is equal to whatever this is times 1. Well, then you're just saying that my y-intercept is whatever this is. Does that make sense to you? All right, cool. So if I ask, what's the initial amount of stuff that you started off with? The answer is 500. All right. How much stuff is left after 3 years? For that, you would just say, well, what is P of 3? Does that make sense? So you just take 0.8. There's no way. See, Lucas, are you saying there's 256,000 grams left after T years? Oh, no. The reason why Lucas is crazy is because this thing is decaying. So the number that you get should be smaller. And I think the reason why, what Lucas was saying is that this number right here, he put in an 8 on accident. So 0.8 to the third power times 500. That's different. Does that make sense? Yeah, it should be smaller because it's decaying. In fact, this number right here is kind of basically saying that every year your amount that you have goes down by 80, or not down, it goes down by 20%. Or every year you have 80% of what you had the previous year. Does that make sense? So if this number right here is a number that's bigger than 1, like it's 1.5 or 1.2 or 1.25 or whatever, then that would say that you're increasing. So you have this exponential increase. So that would be like, what is the population of rats when you leave them inside of a ship and they have unlimited amount of food to eat? That would be an exponential increase. See, what's really interesting about this stuff is it doesn't only apply to money, but it applies to like almost everything. The value or this exponential growth and exponential decay is like probably the biggest thing I can see that relates math to biology. Okay, does this stuff make sense to you? Yeah, the Fibonacci sequence appears everywhere. Well, this is kind of exactly related to the Fibonacci sequence. All right. This part, to be honest with you, I don't know how to tell you to do this one. And the third question is, how many years would it take if you only have 10 grams left? Okay? So what we're saying to do is we're saying, let this thing equal 10. And what I want to do is I want to figure out what t is. To be honest with you, I don't know how to do this problem. It's not that I don't know how to do this problem at all. I know how to do this problem. It takes some mathematics that I'm not ready to teach you about yet. I should probably teach it to you soon. And I think I will be teaching it to you this year. I just don't think I'm ready to teach you this now because it's a little confusing. So it is, I do hate to say it, but it is trial and error. I'll show you what you have to do, okay? What I would do is this. I'd go back to this thing right here, and I would graph it using Desmos. I should call this, instead of a Y, I should call it a P, because that's what we use, P. We cool? And Desmos is going to graph it like this. It's going to start at 500 over here. And it's going to exponentially decay as time gets further on and on and on. Are we cool with that? Yeah, you can use Desmos to find it. All right. What I'm asking here is I'm asking, at what time does P equal 10? So over here it's 500. So what you do is you say, okay, well, if P equals 10, you can look on your graph and you can say, well, what time is that? And then you basically just guess that time. So you say, well, if that's 10, then what is the t value that will give me this value right here? That's what you're looking for. And so you basically take that number and you say, that's my answer. Because in all these questions, I'm saying approximately what is this thing? So what I kind of want you to do is be able to go backwards. What I mean by backwards on the graph is usually on the graph we give you this answer, then you're able to look at the graph and go up and then across and figure out what this answer is. Well, in this case, I'm doing it backwards. I'm saying, if this is 10, what is the t value that gives you that true answer? We cool? I could show you a very mathy way to do this, but it involves logarithmic formulas and all of that kind of stuff. And I'm not ready to teach that to you just yet. So my question was, with this problem, and I think this is problem number 4 on one of your homeworks, is at what time do you only have 10 grams left? So you start off with 500 grams of this stuff, okay? And then you wait a certain amount of time. And after 1 year, you have 80% of that amount of stuff left. After 2 years, you have 80% of that 80% of the stuff you had left. After 3 years, and so on and so forth. At what point do you only have 10 grams of the stuff if you started off with 500 grams? And like I said, the best way for me to show you how to do this is to graph it and then plug in 10, or you don't plug in anything, you just say, you look at 10 and you say, which value of t, this number here, gives me a value of 10. And then what you could do is you could plug in that number that you guessed into this part right here and see how close it gets you to 10. Do you get it? Does that make sense to you? All right. Let's try this one. Yeah, you can use Desmos. You can use Desmos for all of my homework. Here's a good one. A equals P naught times RT. Now, I changed that from P equals P naught times RT to A. I'm just saying the amount is equal to P naught times RT. Cool? Like I said, I'm going to change the letters on you, but it's really the same exact form. Now, this problem says, this is like number 6, I think. It says, suppose that you have $1,000. So your principal amount was $1,000. Got it? And then, in 7 years, that thing doubles. So if t equals 7, then A is equal to $2,000. What is your R value? What is your rate? You guys get it? So let's plug in the numbers. It's 2,000 is equal to 1,000 times R to the 7th power. What is R? Let's see, do you guys have the math to do that? Let me see if I can figure that out. I want to get R by itself. This is 1,000 times R. So, oh no, it says, the problem says you start off with $1,000. You put it in an account for 7 years, and it's now $2,000. It doubles. The amount of money you have in the account is $2,000, or it just says doubles. So I wrote down $2,000. So what is the interest rate? And so let's see. In order to figure this out, you just make it 2 is equal to r to the 7th power. You guys understand how I got 2? I just took 2,000 divided by 1,000. 2. There we go. And then in order to get rid of this to the 7th power, I just bring it to the 1/7 power. Do me a favor. What is 2 to the 1/7 power? I don't have a calculator on me. You're going to have to help me out here. $1.104. All right. Then here's my question. What was the percent interest on that account? There we go. Very good. About 10%. Because remember, this thing is increasing by 1.104%. That one, the first one, comes from, well, it still has all the money you have initially. That's the 100%. So we need to take that off. And you're left with 0.104. But written in percentage-wise, that's 10.4% because you move the decimal place around. So when you go to the bank, you're going to look for an interest of 10%, or maybe, let's make it 10% increase, and then that's about the percent increase that you would need if you wanted it to double. If you invest some money and you wanted it to double, and it occurs interest at 10% every year, and you leave it in for 7 years, it will double the amount of money you have in there without having to touch it at all. Are we cool? Make sense? All right. You're right, Lucas. It's time for me to go. On Friday, I'll cover, or next week, Monday, I'll cover with you guys this compound interest and E. And this is where we're really getting into some heavy stuff. Cool? But for the most part, let's see, hold on. For the most part, this thing is pretty, class on Monday is 1:30 like usual. Yeah. For the most part, this stuff is pretty much just take what I taught you and apply it. And they might change the letters on you a little bit, but don't freak out. They're doing it because they're applying it to different situations. We cool? All right. Talk to you folks later. Okay. But, hey, Bradley, we good?
You are currently the only person in this conference.
Okay, I guess we're good then.